Welcome to the Explainer. So look up at the sky on literally any given day. You're not just looking at clouds or, passenger jets heading off on vacation. You are actually looking at a massive, completely hidden, and highly calculated invisible machine. I'm talking about the global air cargo network. This is the fragile colossus that literally powers international trade. It's an insane industry built entirely on absolute precision, moving millions and millions of dollars of high-stakes freight across entire oceans in just a matter of hours. But beneath all of this breathtaking logistical choreography, there's a deep, deep vulnerability that we are really only just starting to fully understand. Which brings us to the ultimate question, doesn't it? What happens when the sky closes? As we're going to see today, we spent decades building these systems of absolute mathematical perfection to govern exactly how goods move around the planet. But those perfect systems, they have to operate in a highly unpredictable physical world. So what exactly happens when our beautiful, flawless equations crash headfirst into a suddenly closed airspace? Well, let's find out. Okay, let's dive into this. Our anchor point for this explainer is the year 2026. This is the moment where the sheer scale and really the high-stakes nature of modern global logistics truly crystallized. We're talking about a year completely defined by trying to optimize every single millimeter of a supply chain. Because in this world, a 1-hour delay doesn't just mean you're late, it can cost literally millions of dollars. You had researchers pushing the absolute boundaries of technology to perfect these networks, while simultaneously facing sudden, real-world physical bottlenecks that threw those very optimizations into total chaos. Section 1. Optimizing the skies. Let's look at how we've been trying to perfect this invisible machine. If you take a look at the intense academic research surrounding air cargo, it generally falls into a few major buckets. You've got experts who are constantly analyzing the core nexus between air cargo and international trade. And a really prime example highlighted in the research here is Taiwan's high-technology industry. Think about it. When you're shipping microscopic, wildly expensive tech components globally, you absolutely cannot afford a single delay. Your stress levels as a logistics manager, they're tied directly to achieving absolute, flawless optimization. And to get that kind of peace of mind, the industry has gone all in on extreme digitalization. What's really interesting about this slide is how these academic studies essentially treat global logistics like a giant solvable puzzle using some incredibly dense mathematics. Take something called inventory transshipment modeling. Now, this is not just your basic everyday scheduling, right? This is a highly complex mathematical approach used to completely optimize air cargo revenue management. It's designed to fine-tune intercontinental supply chain routing down to the absolute minute. They're literally trying to engineer certainty out of a totally chaotic world. And to actually process all of this insane data, the industry is digitalizing at a breakneck pace, relying heavily on systems like AI cargo. This is a cutting-edge, data-driven revenue management system that's explicitly designed to forecast time series data with incredibly high stakes. The whole goal of AI cargo, and models just like it, is to completely maximize network efficiency. They want planes perfectly loaded, perfectly routed, and perfectly timed. It's the ultimate pursuit of a mathematically pristine global supply chain. And they're pushing the boundaries even further. The academic sources we're looking at show researchers leveraging some absolute sci-fi level futuristic technology. We are literally talking about utilizing quantum computing in logistics. They're pairing that with wild concepts like fuzzy location network design to flawlessly map out intercontinental hubs. I mean, on paper, it is an unbreakable, perfect web of global delivery. But all of this beautiful theory brings us to a massive, dramatic pivot. We have these quantum computers and artificial intelligence telling us the absolute 100% best way to move cargo from point A to point B. But what happens to a mathematically perfect supply chain when the actual sky closes? What's the fatal flaw hiding inside all these optimized high-tech systems? And this brilliantly illustrates the exact problem. We're pitting theoretical math against harsh physical reality. You can have the most advanced fuzzy location network design in the entire world, powered by quantum computing and state-of-the-art AI. But if a sovereign nation suddenly declares its physical airspace is closed, your beautiful, perfect mathematical model instantly hits a brick wall. It's this clean digital control slamming right into an unpredictable, messy physical blockade. Which brings us to Section 2, when reality hits. Let's zoom in on a specific catastrophic disruption. Let's drop the anchor of reality right here. On March 11th, 2026, Qatar Airways Cargo, literally one of the leading global trade companies on Earth, released this urgent update. Quote, Qatar Airways Cargo's scheduled flight operations remain temporarily suspended due to the closure of Qatari airspace. End quote. I mean, wow, the sky literally closed. Despite all the AI forecasting, despite all those revenue management models working perfectly in the background, this massive logistics giant was forced to simply stop. So when that airspace closed, Qatar Airways had to instantly shift into pure survival mode. And we're talking grounded, highly practical steps here. That meant immediately suspending scheduled flights. It meant scrambling to operate these limited, non-Doha freighters just to keep a tiny trickle of trade alive. They had to slap strict temporary restrictions on booking and accepting any new shipments. And the customers? They were left constantly refreshing qrcargo.com just to track their reroutes. It was incredibly practical and, as you can imagine, unbelievably stressful. The stark juxtaposition here is just fascinating. On one hand, you have academics studying air cargo using phrases like a hybrid approach based on reliability theory and fuzzy logic, which, let's be honest, exudes this aura of total, absolute control. But then you look at the actual corporate alerts sent to the public. We sincerely apologize for the inconvenience, which is beyond our control. Beyond our control. Right there, in the face of a closed sky, all that confident academic reliability theory yields to absolute helplessness. Section 3, Managing Systemic Risks. Let's look at how the industry is actually learning from this collision of theory and reality. So the crucial point is this. If we look at a 2026 bibliometric analysis tracking academic trends, it shows a massive fundamental pivot. Researchers are shifting heavily towards studying risk management in air cargo logistics. Basically, academics are waking up to the fact that all the AI, all the quantum computing, and all that dense transshipment modeling, it absolutely has to account for unpredictable, messy physical risks now. They're realizing they need to study how to actually predict and survive a real-world physical bottleneck, rather than just mathematically avoiding a theoretical one. Which leaves us with this final, vital thought to take away from our explainer today. We have built this incredible, mathematically gorgeous system to move the world's economy through the clouds. But if the most advanced artificial intelligence and the most powerful quantum algorithms cannot physically force open a closed airspace, then how resilient is our global supply chain really? It truly is a fragile colossus. And understanding that fragility, well, that's the absolute key to navigating the future of global trade. Thanks so much for joining me today, and keep questioning the systems around you.